Rounding. To begin, we will discuss a couple ideas that may initially not seem to be related to the idea of rounding, but they will be important in that discussion. We need to consider the nature of decimals on the number line. So the first question, how many numbers are between 3 and 4? Think about this for a minute. On the number line, how many numbers are between 3 and 4? Of course, there are no integers between 3 and 4, but that's not the question. I'm not asking about integers. I'm asking about numbers in general. There are decimals between 3 and 4. How many of them? Well, of course, the answer is infinity. There's an infinite number of decimals between any two integers. So that's mind-blowing fact number one. Second question, how many numbers are between 3.99 and 4? Well, again, the answer is infinity. And then the next question, now we're getting a bit ridiculous here. How many numbers are between 3 and a whole bunch of 9s after it? Looks like there are 29s after it. Between that number and 4. How many decimals are in that tiny infinitesimal little gap? Well, turns out there's still infinity. This is a really deep idea. Between any two numbers on the number line, no matter how close those two numbers are, there lies an infinity of points between them. That is a very deep idea about the nature of decimals and the nature of the number line. This fact, this purple fact, will not be tested directly on the GRE, but knowing this will give you important perspective in the discussion of rounding. Rounding. So now we can talk about rounding. Let's start very easy. Suppose we are rounding to the nearest integer, and suppose there is only one digit to the right of the decimal point. The rule is very easy. If the number in the tenths place is 0 to 4, then we round down. If the number in the tenths place is 5 through 9, then we round up. Very straightforward. So here, we'll select those, first of all, that are in the first category, the 0 through 4 category. Those all get rounded down. Now the other ones are in the 5 through 9 category. They all have digits in the tenths place that are 5 through 9. And of course, those ones get rounded up. So far, so good. Now we add a twist. We are still rounding to the nearest integer, but now we could have any number of decimals to the right of the decimal point. Here's the tricky part. We look only at the number in the tenths place and no other number. The number in the tenths place is 0 to 4, we round down. The number in the tenths place is 5 through 9, we round up. The subsequent decimals, anything beyond the tenths place, is absolutely irrelevant. Well, here's what I mean by that. So, of course, most people are pretty clear in the fact that numbers like 7.12 or 7.384, those get rounded down. And, of course, 7.96 or 7.532, those get rounded up to 8. Most people get that. But where it gets tricky is when we have a 4 in the tenths place with more digits behind it. So, for example, 7.45, that has a 4 in the tenths place, so that gets rounded down to 7. 7.49 gets rounded down to 7. 7.49999 gets rounded down to 7. Now this starts to confuse people because people look at that and they say, well, gee, 7.4999, that's essentially 7.5. But we have to be very careful here. How many decimals separate 7.49999 from 7.5? Well, as we just talked about, there's an infinity of decimals separating them. And because there's an infinity of difference, one gets rounded down, but 7.5 would get rounded up. As you might infer, a very common mistake, and here's the mistake I'm trying to target, the mistake of double rounding. People look at something like 6.48, and we have to round to the nearest integer, and so they do this. They say, oh, well, first of all, let's look at that 8. That 8 gets rounded up, so the 4 gets rounded up to 5, and now the 5 has to round up the 6 to 7. And so what we've done is we've done rounding in 2 stages here. This is 100% incorrect. This is not what you are supposed to do. Instead, you have to look at that 4. The 8 is irrelevant. Look at the 4. The 4 gets rounded down, and so 6.48 gets rounded down to 6. Very important to avoid double rounding, which is a very common mistake. Now we are ready to generalize. The GRE could ask you to round to any decimal place, the nearest hundreds, the nearest thousandths, etc. When you're asked to round to a place, look only at the digit in the next place to the right, the next smallest place. The same rule as above, 0 through 4 rounded down, 5 through 9 rounded up. For example, if we're going to round this number to the nearest 1,000, well, we look at the number in the next place, the hundredths place. That number is a 5, so we're going to round up. And so that means it gets rounded up to 66,000. That's the nearest 1,000. So here are some practice ones, and I'd suggest pause the video here and practice these on your own. And here are the answers. In this video, we discussed the rules of rounding and covered the mistake of double rounding.